So we are going to discuss about data warehouse and OLAP. We are going to learn about the basic concepts and the data warehouse modeling, data warehouse design and usage and implementation. So what you need to learn here is the terminology of data warehouse. Data warehouse, mostly people will say it as OLAP. OLAP means the online analytical processing. The other key word is transaction DB. It is online transaction processing or OLTP. So we can see what is the definition of the data warehouse. There are many definitions of the data warehouse. It defined in many different ways, but not rigorously. I can say in simple word, it is a decision support database that is maintained separately from the organization's operational database. And it supports information processing by providing a solid platform of consolidated historical data for the analysis. So the data warehouse mentioned by this guy is a subject-oriented, integrated, time-variant, and non-volatile collection of data in support of management's decision-making process. We call data warehousing, it is the process of constructing and using data warehouses. So we are going to learn what are they. Okay. There are four properties, as I mentioned: subject-oriented, time-variant, non-volatile, and integrated. So the first is subject-oriented. It means that it is organized around major subjects, such as customer, product, sales. So if you are dealing with the operational means the daily operation or the daily transaction, you will have the table or the database for order processing. Or you may have table about customer loans, or you will have table about consumer billing, account receivable. But if you are dealing with the data warehouse, you can divide with the subjects. For example, if it is about sales, then yeah, it is the combination of the order processing and maybe consumer billing. If it is related with the product, so maybe it is related with the accounts receivable and the order processing. So the data warehouse is basically based on the subject, and it is focusing on the modeling and analysis of data for decision makers. So the keyword is this one. It is for decision makers, not on daily operation or transaction processing. And it provides a simple and concise view around particular subject issues by excluding data that are not useful in the decision support process. So we do not include, we exclude the data that are not useful, because the key point is just for the analysis for decision makers. So some data might not be useful. That's why we call it, this is subject oriented. It depends on the subject that you want to analyze. Integrated. It is constructed by integrating multiple or heterogeneous data sources. So you can have the relational database, or you can use flat files, or you can use online transaction records. If you're happening in the company, yeah, you have the CRM, you have the ERP, or you have any other data sources, and you can combine those data sources into one single data warehouse. So whenever you want to create a report, or you want to make a budgeting, or you want to show the dashboard, so those should be from the data warehouse. And when you want to integrate, it means you will apply some data pre-processing, like data cleaning or data integration. It is to ensure the consistency in naming conventions. So you learn from the previous sections when you have the name like Bill Clinton. Okay? It can be Bill Clinton, or it can be Bill W. Clinton, or it can be William Clinton, but they are the same name. Or yeah, like the president of South Korea now is President Yoon Suk Yeol. So some media maybe they mention President Yoon Suk Yeol with dash, President Yoon Suk Yeol without dash. So some of them might not have the consistent name. So we need to ensure the consistency. And then there can be some encoding structures or attribute measures. So last time I mentioned to you, in Korea, we can measure the length with centimeter or meter. If you go to US or if you go to UK, they use feet, they use inches. Okay? So they have different measures. Or for example, the hotel price. If you want to travel abroad, if you want to go to US, then you need to have the currency of US dollar. So we need to have the currency exchange. Or if you want to go to an hotel, the tax will be different. The tax in Korea will be different with the tax in Japan. And there can be also different whether the hotel provides breakfast or not. So there should be a consistency between the data if you want to put it into one data warehouse. So when the data is moved to the warehouse, it is converted. So every data in the original data, when you move it to data warehouse, it should be converted, or we can say this is the integrated. And the data warehouse is a time variant. The time variant means we have the time horizon. The time horizon for the data warehouse is significantly longer than that of operational system. We have two kinds of database, operational and data warehouse. The operational database, it applies the current value data. The time horizon of the operational usually is about like 60 until 90 days. Because sometimes you can modify, sometimes you can edit or delay the data. So it should be valid on some periods of the operational. You can update the records. So the key structure may or may not contain an element of time. So just contain the record. But the data warehouse, it provides information from a historical perspective. For example, 5 until 10 years. So the time horizon is longer. We want to create the 5 years data. We want to create 10 years data. So it has a sophisticated snapshot of data. And the key structure contains an element of time. So you need to know what is the data on January, what is the data on 2012, what is the data on the quarter 1 in 2015. So every key structure in the data warehouse, it contains an element of time, explicitly or implicitly. But the key of operational data may or may not contain time element because it is just operational data, so they don't have any time element sometimes. But some of the operational data, they also contain the time element. Non-volatile. Non-volatile means it's not connected. So once the database of OLTP is changed, there will be no changes on data warehouse because it is not connected. Or we call it, this is a physically separate. A physically separate store of data transformed from the operational environment. Operational update of data does not occur in the data warehouse environment. So whenever you do the OLTP, usually we will use the C R U T. So C, it stands for create, R stands for read, U stands for update, D stands for delete. So for every data that you save into the database or the transactional database, you can create, you can read the data, you can update the data, and you can delete the data. So it does not require transaction processing, recovery, and concurrency control mechanism. So in this data warehouse, we don't need this transaction processing because this is the transaction processing. And sometimes the OLTP, it requires the recovery. So if the database is down, then you need to have the mechanism for recovery or the concurrency control mechanism. So when you update your data from the mobile phone, I should see the same data in my website. So there should be the concurrency in the transactional processing or OLTP. But for the data warehouse, it does not require for this one. So the data warehouse requires only two operations in data access: loading and access. So we just need the loading and access. Loading and access the data. So that's the main difference between the data warehouse and the transactional database. And whenever you have the OLTP, it is for the operational system application. If you have the data warehouse, it is for the decision support system. So the data warehouse itself is a kind of multi-tier architecture. You have the operational database, and sometimes you will also have the external sources. These external sources, it can be anything. For example, you have a logistic company. So as a logistic provider, you need to consider the weather. If today is raining, then you need to consider how many trucks that will go. If it is bad weather and you run an operation for the logistic using airplane, then you need to check and you need to put also those data. We have ETL. You still remember what is ETL? It is from extract, transform, and load. Okay. We want to extract the data from the operational database, transform the data into some format, and load those data into the data storage or repository. There should be some monitoring or some administration before we enter the metadata repository, and after we see the proper metadata repository, we can create the data warehouse and we can create a data mart. So warehouse is the big one, and then we will have the smaller. We call it the data marts. Let's say if I have a manufacturing company. So the manufacturing company will have the data warehouse, and we can have the data marts related to the production. So data warehouse for production only, or data warehouse for supplier only, or the data warehouse for customer only, or the data warehouse for the delivery only. Okay. So we call those items as a data marts. After we have the data storage, we will put it into the data engine. We can have the server. Yeah, the server can be anywhere. It can be in the company or it can be in the cloud and etc. And finally, we can make the report, or we can query. We can do the analytics, and also we can do our part, the data mining. With this kind of diagram, you know that you can do the data mining from the data warehouse and do not do the data mining from the operational database, because the operational database still have many noise. There are many missing values. There are many values that you need to transform before you do the data mining. So this is the difference between the OLTP and OLAP. The OLTP is more about the clerk or IT professionals. So you need to input and then you need to insert the data into the database. But for the OLAP, it's more about the knowledge worker. You need to do the analysis. The function in OLTP is more about day-to-day operations. But the OLAP is more about decision support. For the DB design, it's more the application oriented. It depends on the application. If it is bank, of course, it is about the services in the bank. If it is about mart or the supermarket, of course, it is about the sales transaction. But the OLAP is more about the subject oriented. The data is current, up to date, detailed, flat, relational, or isolated. But the OLAP is more about the historical data, summarized, multi-dimensional, integrated, and consolidated. The usage is repetitive. You need to do one day, maybe multiple times. But the OLAP, you need to do it ad hoc. When you need to decide something, you will check your database. The access for the DB is more about read, write, but the OLAP is more about lots of scans. If the work is about the simple transaction for OLTP, for the OLAP is more about the query. And the record that you want to access for the OLTP, usually it is not that much, it's not many. But for the OLAP, you need to handle millions because it is for the big data. When you have the users, the OLTP maybe the users is more than the OLAP, because you need to know the customers, you need to access the suppliers, you need to know the machine, the workers, and etc. So there will be a lot of users. But for the OLAP, it's only for the management, or it's only for the directors. So the users will be less than the OLTP. The DB size, usually for this transactional, is less than the OLAP, because you are going to do the transactional. After you finish with the transaction, you will save it into the data warehouse. And the data may be, as you know, it may have only 90 until 60 days. So it's short. But the OLAP, it is for 5 until 10 years. So it means it's very huge. And the metric, usually we use the transactional throughput. So how many transactions in a day? But the OLAP, we use the query throughput. So what is the result from the query? So why we need a separate data warehouse? Because we have the different performance. The OLTP, it requires high performance to access. It requires high performance to do the indexing. It requires high performance to do the concurrency control. And it requires a high performance for recovery. The data warehouse, it also requires high performance for complex queries. And it also requires high performance for multi-dimensional view and consolidation. So that's why it is good to separate data warehouse. The database for operational should be separated with the data warehouse. And it has different functions and it has different data. The decision support requires historical data which operational DB do not typically maintain. So the missing data are a lot in the operational data. But when you do the analysis, when you have missing values, it will degrade the quality of your analysis. So when you do with the analysis, you need to handle the missing value. You need to handle the missing data. The data consolidation, it means it requires the consolidation like aggregation, summarization from the heterogeneous sources. But for the operational, you do not need to do this consolidation. And the data quality, different sources typically use inconsistent data representation, or sometimes they use the different formats, different codes that you need to reconcile. But in the transactional, you don't need to do that. So now, note this one. There are more and more systems which perform OLAP analysis directly from relational database. Nowadays there are more and more OLAP that can be combined with the operational database. But the concept is, both of them should be separated to make a high performance for both of the systems. There are 3 data warehouse models. The first is the enterprise warehouse. It collects all the information about subjects spanning the entire organization. It means the whole organization should be in one big enterprise warehouse. Data mart. It is a subset of corporate-wide data that is of value to a specific group of users. So its scope is confined to specific selected groups such as marketing data mart. So if you are focusing on the marketing, then you will have a data warehouse for marketing only. If you are focusing on the production, then you will have another data mart for only production. If you are focusing on the purchasing, so you may have another data mart, which is the purchasing data mart. So it is the subset. Virtual warehouse. It is a set of views over operational database. If you learn about database, there will be the word about query. So when you do query, it means you want to get some data based on conditions. Maybe the condition is you want to get some data on January. You want to get the data on February. Or you want to get the data from Mr. Kim. So after we have the query, we can put the result of the query into one views. So this is from the operational database. It means if I want to create views from the operational database, I do not need a particular data warehouse. So it is like a temporary data warehouse. So that's why they call it the virtual warehouse. Or yeah, we can say the temporary warehouse. Only some of the possible summary views may be materialized. So if we can get the query, we use that query for our data warehouse. So this is the ETL. We can have the extraction, transformation, and loading, ETL. So the data extraction means we get data from multiple heterogeneous external sources. After we do the extraction, we can clean. It means we detect the errors in the data and rectify them when possible. We do the data transformation because we need to convert the data from the legacy, from the original data, to host the same format in the data warehouse. And we need to load the data. So loading the data, it can be sorted, or it can be summarized, it can be consolidated. We can compute the views, check the integrity, build the indices and partitions. And at the end, we can refresh. Maybe after 1 year, we want to get a new data from the previous year. So we will propagate the updates from the data source to the warehouse. Okay, learning check. Mention 4 characteristics of the data warehouse. What are they? They are subject oriented, and then we have time variant, and then it is integrated, and it is non-volatile. Okay, so those are the things that you learn. What is the main difference between OLTP and OLAP? OLTP is the transactional, or it is about operational. What about OLAP? OLAP is more for the decision support, or it is for the analysis. Okay. There are three data warehouse models. Can you mention them? We have enterprise warehouse. We have data mart, and we have virtual warehouse. What is enterprise warehouse? It will manage the entire organization. What is data mart? It is a subset of the organization. So if you are dealing only with the marketing, then we have marketing data mart. If we have only the production, we have the production data mart. What is virtual warehouse? It is a set of views from operational database. So you can just extract from the operational database into a view, and you will use the view for your analysis. Explain the main task of ETL. E means extract. So it means you can extract or integrate from multiple sources of data. And then you have T, it means transform. You transform the data. So integrate the multiple source of data. You can also do data cleaning here. And then transform. So it means you need to consolidate. Sometimes the data are not consistent. You need to make the consistency. And you need to load. When you load, it means you need to sort the data, or you need to make the summary of the data, okay? Or you need to do the indexing of the data, and so on. Okay, any questions, comments? Okay, if there is no questions, comment, I will stop now.